Here we're going to be looking at one question from this 2009 free response, and it's going to be question B. It's a very popular type of question. And first of all, looking at question A, they're giving us here a rate at which people enter this auditorium, and question A asks for the total number based off a rate. And that would be an integration problem, but that's one that's not going to be asked this year. You're accumulating the rate. So we don't have to worry about that. So we're going to just be looking at B because it's a popular type of question. So it says find the time when the rate at which people enter is a maximum. So the first thing I want you to make sure you understand is don't assume that this is a local or relative, same thing. If it were, then you would just use the first derivative test or the second derivative test, but you can't assume they're looking for local. You should always assume they're actually looking for absolute. So this is where the candidate test comes in. So remember, an absolute extremum will only occur for a continuous function like this at the endpoints or the critical numbers between the endpoints. So they give R is the rate. So we have to figure out where this R is a maximum. So the first thing we're going to do is look for the critical numbers. The critical numbers are where the derivative of the function is 0 or undefined. So critical numbers of this function is R. That's the derivative. T squared. We need to find out where that equals 0. So that's definitely a calculator question. It doesn't have to be, but since you have it, y equals 2760 x minus 25 x squared graph. So we're trying to figure out what this equals 0. So it equals 0. Let's make this bigger. Looks like here and here. So it's the derivative is 2760t minus 2025t squared. So I know 0 is one of them. I don't have to really worry about that. I need to find this one right here. So I'm going to go second calc 0, and then left bound. It looks like it goes through 1 point something. So my left bound is going to be 1. My right bound is going to be 2. My guess is going to be enter. And there it is. My critical number, therefore, is 1.36296. So make sure you keep this bigger than 3 decimal places because it's not your final answer, it's an intermediate answer. So now I'm going to actually do the candidate test. The candidate test says the only candidates for a max or a min are the endpoints 0 and 2, and any critical number between 0 and 2, which we just found. So we're trying to figure out where R of t is the maximum. You just plug in all three candidates, and the maximum would be the one that produces the biggest number. So again, this is a really good calculator question. I'm going to now type the actual function in the calculator. I have to find it. The actual function is 1380 t squared. That's -1, that's not squared. Minus 675 t cubed. It's hard to, I know I accidentally put plus there, I want minus. So now I'm going to go and get those values. So to get the values, second calc value. 0 enters my first one. I know what that's going to be. That's going to be 0. 1.36296. Value there is 854. I can't read that. 854. 0.5273, and finally I'm going to plug in 2 to enter, and you see we get 120. So as far as the work goes, that's why I wanted you to kind of make it through this video. This is the candidate test, and this showed us that we checked every possibility where there can be a min or a max. So that's the work that you would need to show. And the question was, find the time when the rate is a maximum. So the rate was 854.5273, but at the time, so this would be your answer, and just state that. That's it. Now this is embarrassing. I don't know how to turn this off since I hit that thing. So I'll have to go through here.